Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 2, Lesson 12, Interval Notation. We will often want to talk about continuous segments of the real number line. We've already done work with this in the last lesson using what is known as inequality or set builder notation. Today we will see a very simple way of showing these segments. However, this is not only very simple, it's going to be used very often throughout our course, so we have to make sure that we understand the notations that go along with a closed circle and an open circle. For each of the following in exercise number 1, graph the portion of the number line described by the inequality and then write the equivalent using interval notation. So exercise number 1A, sorry for that truck. Exercise number 1A, -3 less than or equal to x less than or equal to 5. Well, I want to start off by putting a solid dot on -3. How did I know it was a solid dot? Well, I knew it was a solid dot because of the inequality symbol right here. It says equal to, so it means it's a solid dot. Then I'm going to put a solid dot on 5. I'm then going to shade in between. How do I know it's in between? Well, I've taught you that this is an AND statement. An AND statement looks like a dumbbell, so that's what I wanted to make it look like. Also, notice how the x is in between my two numbers. Notice that? That's where my x would sit. So these are all my possible x values. The last step that they would like us to do today, and I'm going to do it in gray throughout the lesson, is to write that in interval notation. I want you to understand that a closed dot means included. So I'm going to have a bracket, that means closed dot, and that means included. -3, comma, 5, bracket. This dot tells me bracket. This dot tells me bracket. Let's look at B now. B is going to say, it says -6 less than x less than 4. So that means I'm going to have an open dot on -6, open dot on 4, and I'm going to shade in between. My x is in between my numbers, so therefore I'm going to have a dumbbell. This is an AND statement. Don't forget that. It is an AND statement. Looks like a dumbbell. My x sits right inside there. The last piece is writing my interval notation. With an open circle, that means I'm going to use parentheses. -6, comma 4, close my parenthesis. Noticing that less than symbols without the equal to bar have parentheses. Open circles, parentheses. See how they all go together? Now let's look at C. -4 less than x less than or equal to 8. So I'm going to go ahead and put an open circle on -4 and a closed dot on 8. The reason why it's closed, is because of the equal to bar. I'm going to then shade in the middle. It is an AND statement. My x will go right in the middle there. These are all my x values. Now all I have to do is write my interval notation. I'm going to have parenthesis, -4, comma, 8, bracket. Paying attention one last time. It does not have an equal to bar, so that's why it's a parenthesis. This has an equal to bar, that's why it's a bracket. Notice they match. Parenthesis goes with my open circle. Bracket goes with my closed dot. Now we're going to jump to using the infinity symbol and dealing with the word or. The first one, x is greater than or equal to 4. I'm going to put a solid dot on 4 because it says greater than or equal to. And then I'm going to shade to the right. Don't forget, I'm shading in all of the values that could be placed in for x that would make that statement true. The last step that we have to do today, or in this problem, is write our interval notation. So I'm working left to right. I'm going to say, all right, what kind of dot do I have? It's a solid dot, so I'm going to have a bracket, my number 4, comma. When you see the shaded arrow in here, it's going to tell me that it's a positive infinity. So you're just going to write infinity, and that's a sideways 8. Infinities always get locked in with a parenthesis. That means it keeps on going. Number 3. It says x is less than 5. Because it says less than, I'm going to have an open dot on 5. My variable is out front. My inequality is pointing to the left, so I'm going to shade to the left. My shading tells me all of the possible values that could go in for x that would make that statement true. Once again, working from left to right, I see a shaded arrow, a nice big arrow. So that means I must be starting with a negative infinity because it's on the negative side of the number line. Infinities always get locked in with parentheses like I said earlier. 5. And the last thing I see is that open circle. Open circles mean they get parentheses. Hope you're catching on to this. F gets a little tricky. Remember what I said to you about always wanting the variable out front. So what I'm going to do is just do a quick little switcheroo to make this problem a little bit easier. I'm going to bring the x out front. I'm going to bring the negative 4 to the back. I'm going to pay attention that the inequality is eating the x and it's open towards the x, so I'm going to keep it that way. Notice what happens. It flips around. Both statements mean and say the same thing. This way it's just a little bit easier to graph. So that means I know I'm going to have an open dot on negative 4. My inequality is pointing to the right, and my variable is out front now, so I know I'm going to shade to the right. There's nothing different now with when I'm writing my inequality or my interval notation. Starting left to right, I see an open circle, so it's going to be a parenthesis, negative 4, comma, positive infinity. Infinities always get locked in with what? Parentheses. Now I'm going to put D and E together. I'm going to have a compound inequality with the word or in it. So I'm going to have a closed circle at 1. And I'm going to have a closed circle at 1 because of this inequality right here. It says less than or equal to. So I'm going to go ahead and put a closed dot in on 1. And I'm going to shade to the left. Nice big shaded in arrow. Then I'm going to have an open circle at 5. And I'm going to shade to the right. With all the work we've done in the last couple days, you know that this is an OR statement because I can go ahead and draw in my little guy in his rowboat with his oars, and he can be paddling his boat with his oars. So that's how we remember that's an OR statement. Now let me go ahead and show you how to draw this as an interval notation. Starting from my left, I have negative infinity. That always gets locked in with the parenthesis, comma, 1, and the dot there tells me that it's going to be a bracket. Or, the OR symbol is a giant U. Keep going left to right, starting with the open dot, parenthesis, 5, comma, positive infinity. That's how you write a compound inequality for an OR statement. Go ahead and hit pause at this time and complete exercise number 2 on your own. Alright, now that you're back, exercise number 3. 12 minus 4x is greater than 0. Well, I want to just go ahead and solve this guy. So I'm going to see how I can move this positive 12 to the other side. As we do these problems in class, I notice that you're forgetting that there's a positive 12, the positive for that 12 sign, or the 12, and I want to subtract 12 on both sides. It's going to cancel out. Negative 4x is greater than negative 12. I'm going to divide by negative 4. Divide by negative 4. Because I'm dividing by a negative, right away, I do this, and I'm going to circle it in orange. I divided by a negative. That means I have to flip my inequality. x is going to be less than now positive 3, because negative 12 divided by a negative 4 gives me 3. What does that mean for my number line? Well, I'm going to have an open circle on 3. I'm going to be shaded to the left. Let's write that interval notation. Starting from the left-hand side, working to my right, I'm going to start off with a negative infinity, parentheses, blocks in that, comma, 3, open parenthesis. Remembering that that open dot tells me parenthesis. Shaded arrow tells me parenthesis and negative infinity. A couple last examples just solidifying what we've seen and what these compound inequalities look like. Going from interval notation right to graphing now. I see a bracket on the negative 3, so when I bring that down, I know that's going to be a solid dot on negative 3. I see a parenthesis on the 2, so that means I know that's going to be an open circle on 2. And I know because that is an and statement, there is no infinity symbols, I'm going to be shading right through the middle. That is a dumbbell, that is an and statement, and that's how I go from interval notation to an and statement. Now on page 24 where we are at, exercise 4B, I would like you to write this problem in right here. Negative infinity to 0 or 4 to positive infinity. Write that in instead of what they have there for inequality number 2. And now I'm going to show you how to graph that. It says that I'm going to have a closed circle on 0. I'm going to have a closed circle on 0 because of this bracket. It says that I'm going to shade to the negative infinity. So I'm going to shade to negative infinity, put a nice big arrow in on that. Don't forget that this U means that it's an OR statement, so I'm going to have a gap here, a little bit of a gap. And that parenthesis on the 4 says I'm going to have an open circle on 4, and I'm going to shade to positive infinity. That's how you go from interval notation to graphing. At hydraulic plant pump number 1 is on for all times on the interval from 0 to 8. So I'm going to have a closed dot on 0 like I have, and I'm going to have an open dot on 8. And I'm going to shade in between that because this is when pump number 1 is on. I am then going to have a closed dot on 4. And I'm going to have an open dot on 18 because that is for pump 2. And watch where now I'm going to shade these guys. So the question is, which of the following represents all times T when both pumps are on? So I want to see where the pumps 1 and 2 overlap. Well, they overlap in this area right here. Notice where I ended my black mark. Does it go to 8? No, it does not go to 8 because 8 is an open circle. So we have to pick which choice represents that. Well, I know that I'm going to have 4. I know that I'm having a closed dot on 4, so that's less than or equal to. My x is in the middle. And then either you're going to have 7 with an inequality that's closed, or you're going to have an 8 with an inequality that's open. And in this case, in your choices, it's less than 8. I wanted you to understand that this is also an option, or that is not an option. I want you to just notice that the 7 is not there, so that's why this is the correct answer. At this time, make sure you write your WSQ. There's a lot of great little helpers in this video, and you can be writing down your major key points. Have a great evening.